Hello everyone, and welcome to DevOps for Developers. I first ran into the concept of continuous integration when the Mozilla project launched. It included a rudimentary build server as part of the process, and this was revolutionary at the time. I was maintaining a C++ project that took 2 hours to build and link. We rarely went through a clean build, which created a compounding problem as bad code was committed into the project. A lot has changed since these old days. CI products are all over the place, and as Java developers, we enjoy a richness of capabilities like never before. Today, we'll learn how to incorporate CI into our project and make it more productive. We'll learn how to enjoy the CI process and use it to increase productivity instead of sabotaging it. Finally, we will learn how to get tremendous benefits from the CI process that we can't get otherwise. But I'm getting ahead of myself. Let's start with the basics. Continuous integration is a software development practice in which code changes are automatically built and tested in a frequent and consistent manner. The goal of CI is to catch and resolve integration issues as soon as possible, reducing the risk of bugs and other problems slipping into production. CI often goes hand in hand with continuous delivery, which aims to automate the entire software delivery process, from code integration to deployment in production. The goal of CD is to reduce the time and effort required to deploy new releases and hotfixes, enabling teams to deliver value to customers faster and more frequently. With CD, every code changes that pass the CI test are considered ready for deployment, allowing teams to deploy new releases at any time with confidence. I won't discuss continuous delivery in this video, but I will go back to it as there's a lot to discuss. I'm a big fan of the concept, but there are some things we need to monitor. There are many powerful continuous integration tools. Here are some commonly used tools. Jenkins is one of the most popular CI tools, offering a wide range of plugins and integration to support various programming languages and build tools. It is open source and offers a user-friendly interface for setting up and managing build pipelines. It's written in Java and was often my go-to tool. However, it's a pain to manage and set up. There are some Jenkins as a service solutions that also clean up its user experience, which is somewhat lacking. Travis CI is a cloud-based CI tool that integrates well with GitHub, making it an excellent choice for GitHub-based projects. Since it predated GitHub Actions, it became the default for many open-source projects on GitHub. Circle CI is a cloud-based CI tool that supports a wide range of programming languages and build tools. It offers a user-friendly interface, but its big selling point is the speed of the builds and delivery. GitLab is a popular open source code management tool that includes built-in CI/CD capabilities. The GitLab solution is flexible yet simple. It has gained some industry traction even outside of the GitLab sphere. Bitbucket Pipelines is a cloud-based CI tool from Atlassian that integrates seamlessly with Bitbucket, their source code management tool. Since it's an Atlassian product, it provides seamless Jira integration and very fluid enterprise-oriented functionality. Some CI tools have a simple setup process and user-friendly interface, making it easier for developers to get started and manage their build pipelines. Integration with source code management tools such as GitHub, GitLab, and Bitbucket. This makes it easier for teams to automate their build, test, and deployment processes. Support for different programming languages and build tools, different CI tools, support different programming. So it's important to choose a tool that is compatible with your development stack. Some CI tools are better suited to large organizations with complex build pipelines, while others are better suited to smaller teams with simpler needs. CI tools range in cost from free and open source to commercial tools that can be expensive. It's important to choose the tool that fits your budget. Different CI tools offer distinct features such as real-time builds and test results, support for parallel builds, and built-in deployment capabilities. In general, Jenkins is known for its versatility and extensive plugin library, making it a popular choice for teams with complex build pipelines. Travis CI and Circle CI are known for their ease of use and integration with popular SCM tools, making them a good choice for small to medium-sized teams. GitLab CI/CD is a popular choice for teams using GitLab for their source code management, as it offers integrated CI/CD capabilities there. Bitbucket Pipelines is a good choice for teams using Bitbucket for their source control code management, as it integrates seamlessly with that platform. The hosting of agents is an important factor to consider when choosing a CI solution. There are two main options for agent hosting: cloud-based and on-premise. Cloud-based CI solutions such as Travis CI, Circle CI, GitHub Actions, and Bitbucket Pipelines host the agents on their own servers in the cloud. This means that you don't have to worry about managing the underlying infrastructure, and you can take advantage of the scalability and reliability of the cloud. On-premise CI solutions such as Jenkins allow you to host the agents on your own servers. This gives you more control over the underlying infrastructure, but also requires more effort to manage and maintain the servers. When choosing a CI solution, it's important to consider your team's specific needs and requirements. For example, if you have a large and complex build pipeline, an on-premise solution such as Jenkins may be a better choice, as it gives you more control over the underlying infrastructure. On the other hand, if you have a small team with simpler needs, a cloud-based solution such as Travis CI may be a better choice, as it is easy to set up and manage. Statefulness determines whether the agents retain their data and configuration between builds. Some CI solutions, such as Jenkins, allow for stateful agents, which means that the agent retains their data and configuration between builds. This is useful for situations where you need to persist data between builds, such as when you're using a database or running a long-running tests. There's a lively debate among CI proponents regarding the best approach. Stateless agents provide a clean and easy to reproduce environment. I choose them for most cases and think they are the better approach. Stateless agents can be more expensive too, as they are slower to set up since we pay for the cloud resources that cost can add up. But the main reason some developers prefer stateful agents is the ability to investigate. With stateless agents, when a CI process fails, you are usually left with no means of investigation other than the logs. With a stateful agent, we can log into the machine and try to run the process manually on the given machine. We might reproduce an issue that failed and gain insight thanks to that. A company I worked with chose Azure over GitHub Actions because Azure allowed for stateful agents. This was important to them when debugging a failed CI process. I disagree with that, but that's a personal opinion. I feel I spent more time troubleshooting bad agent cleanup than I benefited from investigating a bug. But that's a personal experience, and some smart friends of mine disagree. Repeatable builds refer to the ability to produce the same exact software artifact every time a build is performed, regardless of the environment or time the build is performed. From a DevOps perspective, having repeatable builds is essential to ensuring that software deployments are consistent and reliable. Intermittent failures are the bane of DevOps everywhere, and they are painful to track. Unfortunately, there's no easy fix. As much as we'd like it, Some flakiness finds its way into projects with reasonable complexity. It is our job to minimize this as much as possible. There are two blockers to repeatable builds. If we don't use specific versions for dependencies, even a small change can break our build. Tests that fail occasionally for no obvious reasons are the absolute worst. When defining dependencies, we need to focus on specific versions. There are many versioning schemes, but over the past decade, the standard three-number semantic versioning took over the industry. This scheme is immensely important for CI, as its usage can significantly impact the repeatability of a build. We can do something like this with Maven. This is very specific and great for repeatability. However, this might become out of date quickly. We can replace the version number with latest or release, which will automatically get the current version. This is bad as the builds will no longer be repeatable. However, the hard-coded three-number approach is also problematic. It's often the case that a patch version represents a security fix for a bug. In that case, we would want to update all the way to the latest minor update, but not newer versions. For instance, for that previous case, I would want to use version 2.3.2 implicitly and not 2.4.1. This trades off some repeatability for minor security updates and bugs. But a better way would be to use the Maven versions plugin and periodically invoke the use latest release command as you see here. This updates the version to the latest to keep our project up to date. This is the straightforward part in repeatable builds. The difficulty is in the flaky tests. This is such a common pain that some projects define a reasonable amount of failed tests and some projects rerun the build multiple times before acknowledging failure. A major cause of test flakiness is state leakage. Tests might fail because of subtle side effects left over from a previous test. Ideally, a test should clean up after itself, so each test will run in isolation. In a perfect world, we would run every test in a completely isolated, fresh environment, but this isn't practical. It would mean tests would take too long to run and we would need to wait a great deal of time for the CI process. We can write tests with various isolation levels. Sometimes we need complete isolation and might need to spin up a container for test, but most times we don't. And the difference in speed is significant. Cleaning up after tests is very challenging. Sometimes state leaks from external tools, such as the database, can cause flaky test failure. To ensure repeatability of failure, it is a common practice to sort the test cases consistently. This ensures future runs of the build will execute in the same order. This is a hotly debated topic. Some engineers believe that this encourages buggy tests and hides problems we can only discover with random order of tests. From my experience, this did indeed find bugs in the tests, but not in the code. My goal isn't to build perfect tests, and so I prefer running the tests in a consistent order, such as alphabetic ordering. We're here to develop a software product, not a CI tool. The CI tool is here to make the process better. Unfortunately, many times the experience with the CI tool is so frustrating that we end up spending more time on logistics than actually writing code. Often I spend days trying to pass a CI check so I could merge my changes. Every time I get close, another developer would merge their change first and would break my build. This contributes to a less than stellar developer experience, especially as a team scales and we spend more time in the CI queue than merging our changes. There are many things we can do to alleviate these problems. Our testing is a common symptom. Overtesting is a common symptom that we can detect with coverage tools. I know deleting or disabling tests is problematic. Don't do that lightly. But if you spend more time debugging the test than debugging your code, its value is debatable. This is something we can do easily in some cases. Just allocate additional or faster machines for the CI process. We can parallelize the CI process. We can parallelize some build types and some tests. Most build systems support concurrent builds and concurrent test execution, which can speed up the results. There are risks, but it can significantly shorten CI cycles. Another common strategy is to split the project into smaller projects. Notice that this doesn't necessarily mean microservices and can mean a modular architecture, as I explained in my recent monolith video. Ultimately, this connects directly to the productivity of the developers, but we don't have profilers for these sorts of optimizations. We have to measure each time. This can be painstaking. GitHub Actions is a CI/CD platform built into GitHub. It is stateless, although it allows self-hosting of agents to some degree. I'm focusing on it since it's free for open source projects and has a decent free quota for closed source projects. This product is a relatively new contender in the field. It is not as flexible as most other CI tools mentioned before. However, it is very convenient for developers, thanks to its deep integration with GitHub and stateless agents. To test GitHub Actions, we need a new project, which in this case I generated using jhipster with the configuration seen here. I created a separate project that demonstrates the use of GitHub Actions. You can see the link in the video description. Notice you can follow this with any project, although we include Maven instructions in this case. The concept is very simple. Once the project is created, we can open the project page on GitHub and move to the Actions tab. We will see something like this. In the bottom right corner, we can see the Java with Maven project type. Once we pick this type, we move the creation of a Maven YAML file. As you can see here, unfortunately, the default Maven YAML suggested by GitHub includes a problem. This is the code generated by GitHub in a more readable form. The last 3 lines update the dependency graph, but this feature fails, or at least it failed for me. Removing them solved the problem. The rest of the code is standard YAML configuration. The pull request and push lines near the top of the code declare that builds will run on both a pull request and a push to the master. This means we can run our tests on a pull request before committing. If the test fails, we will not commit. We can disallow committing with failed tests in the project settings. Once we commit the YAML file, we can create a pull request and the system will run the build process for us. This includes running the tests, since the package target in Maven runs tests by default. The code that invokes the tests is in the line starting with run, near the end. This is effectively a standard Unix command line. Sometimes it makes sense to create a shell script and just run it from the CI process. It's sometimes easier to write a good shell script rather than deal with all the YAML files and configuration settings of various CI stacks. It's also more portable. If we choose to switch the CI tool in the future, here we don't need it, although since Maven is enough for our current needs. We can see the successful pull request here. To test this out, we can add a bug to the code by changing the API endpoint to my API. This produces the failure you can see here. It also triggers an error email sent to the author of the commit. When such a failure occurs, we can click the details link on the right side. This takes us directly to the error message you see here. Unfortunately, this is typically a useless message that does not provide help in this issue resolution. However, scrolling up will show the actual failure, which is usually conveniently highlighted for us as seen here. Note that there are often multiple failures, so it would be prudent to scroll up further. In this error, we can see that the failure was an assertion in line 394 of account resource IT. This is the code of account resource IT, and this is the problematic line 394. This means the assert call failed. Is activate returned false and failed the test. This should help a developer narrow down the issue and understand the root cause. As we mentioned before, CI is about developer productivity. We can go much further than merely compiling and testing. We can enforce coding standards, lint the code, detect security vulnerabilities, and much more. In this example, let's integrate Sonar Cloud, which is a powerful code analysis tool. It finds potential bugs in your project and helps you improve code quality. Sonar Cloud is a cloud-based version of Sonar Cube that allows developers to continuously inspect and analyze their code to find and fix issues related to code quality, security, and maintainability. It supports various programming languages such as Java, C#, JavaScript, Python, and much more. Sonar Cloud integrates with popular development tools such as GitHub, GitLab, Bitbucket, Azure, DevOps, and more. Developers can use Sonar Cloud to get real-time feedback on the quality of their code and improve overall code quality. On the other hand, Sonar Cube is an open source platform that provides static code analysis tools for software developers. It provides a dashboard that shows a summary of the code quality and helps developers identify and fix issues related to code quality, security, maintainability. And Sonar Cube allows a wide range of programming languages such as Java, C#, JavaScript, Python, and more. It provides various plugins and extensions to extend its functionality. Sonar Cube can be integrated with popular development tools such as Jenkins, Maven, Gradle, and more. Both Sonar Cloud and Sonar Cube provide similar functionalities, but Sonar Cloud is a cloud-based service and requires subscription, while Sonar Cube is an open source platform that can be installed on-premise or on cloud server. For simplicity's sake, we will use Sonar Cloud, but Sonar Cube should work just fine. To get started, we go to Sonar Cloud.io and sign up, ideally with a GitHub account. We are then presented with an option to add a repository for monitoring by Sonar Cloud as shown here. When we select the Analyze New Project option, we need to authorize access to our GitHub repository. The next step is selecting the project we wish to add to Sonar Cloud as shown here. Once we select and proceed to the setup process, we need to pick the analysis method. Since we use GitHub Actions, we need to pick that option in the following stage as seen here. Once this is set, we enter the final stage within the Sonar Cloud wizard as seen in the following image. We receive a token that we can copy. From here, we will use that shortly. Notice that there are also default instructions to use with Maven that appear once you click the button labeled Maven. Going back to the project in GitHub, we can move the project settings tab not to be confused with the account settings in the top menu. Here we can select secrets and variables as shown here. In this section, we can add a new repository secret, specifically the Sonar token key and value we copied from Sonar Cloud as you can see here. GitHub repository secrets are a feature that allows developers to securely store sensitive information associated with a GitHub repository, such as API keys, tokens, passwords, which are required to authenticate and authorize access to various third-party services or platforms used by the repository. The concept behind GitHub repository secrets is to provide a secure and convenient way to manage and share confidential information without having to expose the information publicly in code or configuration files. By having secrets, developers can keep sensitive information separate from the codebase and project, protected from being exposed or compromised in case of a security breach or unauthorized access. Secrets are stored securely and can be accessed by authorized users who have been granted access to the repository. Secrets can be used in workflow actions and other scripts associated with the repository. They can be passed as environment variables to the code so that it can access and use the secret in a secure, reliable way. Secrets provide a simple and effective way for developers to manage and protect confidential information associated with a repository, helping to ensure the security and integrity of the project and the data it processes. We now need to integrate this into the project. First, we need to add these two lines to the pom.xml file. Notice that you need to update the organization name to match your own. These should go into the properties section in the XML. Notice that the JHipster project we created already has Sonar Cloud support, which should be removed from the POM file before this code will work. After this, we can replace the build with Maven portion of the Maven YAML file with this code. This code is copied from the Sonar dashboard. Once we do that, Sonar Cloud will provide reports for every pull request merged into the system as shown here. We can see the report that includes the list of bugs, vulnerabilities, smells, and security issues. Clicking every one of those issues leads to something like this. Notice that we have tabs that explain exactly why the issue is a problem, how to fix it, and more. This is a remarkably powerful tool that serves us as one of the most valuable code reviewers in the team. Two additional interesting elements we saw before are the coverage and duplication reports. Sonar Cloud expects tests to have 80% code coverage, trigger 80% of the code in a pull request. This is high and can be configured in the settings. It also points out duplicate code, which might indicate a violation of the don't repeat yourself principle. CI is a huge subject with many opportunities to improve the flow of your project. We can automate the detection of bugs, streamline artifact generation, automate delivery, and so much more. But in my humble opinion, the core principle behind CI is developer experience. It's here to make our lives easier. When it is done badly, the CI process can turn this amazing tool into a nightmare. Passing the tests becomes an exercise in futility. We retry again and again until we can finally merge. We wait for hours to merge because of slow, crowded queues. This tool that was supposed to help becomes our nemesis. This shouldn't be the case. CI should make our lives easier, not the other way around. Follow through the videos to check out the full course. If you have any questions, please use the comment section.